Hi, everyone. My name is Ibrahim. Thanks for joining this session. I hope it will be useful. I know it's the last session of the day, so I will not bother you with an introduction about myself that I would usually love to do. But I've been working in the tech industry across many things for almost 24 years. I work with global organizations, currently with Greenpeace, supporting them in areas of technical innovation and analytics. And you can scan this code to go to my LinkedIn account if you want to stay in touch. I'm quite active and responsive there. So we will talk. Actually, I'm trying to fit a 1-hour session into 20 minutes, and I know this is the last session of the day. So bear with me, and I will do my best to make it less painful as possible. So to the modern data stack. I will talk with you about the modern data stack and what's coming next. You know, with this massive growth in the number of tools that we are seeing every year, I think probably between the moment I started this session and the moment I will end this session, we will have 10 more platforms coming up to fill something in the modern data stack. So what do we do with all of that? How do we make sense of that? And how do we make ourselves and our organizations prepared for this massive explosion? To answer this question, I think it's really important to understand how did we reach this moment? How did things build up till the moment that we live in nowadays? Because if you just see the trajectory of all of that development, you will know where all of this is going on. So there are 3 moments that I think are really crucial to the history of the data industry. And when I say the data industry, you can just replace it with the internet industry, because you will see that the history of data is just the history of the internet. And the first important date was sometime around the year 2000. You know, like this was the boom of the .com. And there has been many companies that tries to fill some gaps in this new industry. So you see that, you know, there has been billions that was pushed into a lot of companies toward the year 2000, and then we have the massive crash where you know, things changed significantly. So there was massive companies that got billions and then just disappeared overnight. We have companies that has been dominating the industry, like Cisco, and now it's not really as dominating as it used to be before the year 2000. So what matters to us in this date is not the companies, really. It's about what happened under the hood to enable these companies to exist. And that was the massive network of fiber optics and cables that connected the entire world. So we have this massive network of fiber optics that made the fiber optics prices decrease. So this is the first important point in the history of data and the history of the internet. And at this point, we say that the world became flat. There's supposed to be audio here, but it's not working. That's OK. So the next moment was a year between the year 2003 and 2007. And during these years, there has been massive growth in many different platforms that shapes the world that we live in nowadays. So in these days, we have Facebook went global beyond the US borders. We have Twitter went global. We have GitHub launched. We have Netflix streaming their first video. I'm sorry, I'm moving out of this. Sorry. And we have the Hadoop launched. We have many things that shapes the days that we live in now, these days. And again, what I want you to focus on is not these technologies. It's about the infrastructure that was required for these technologies to exist. Because if you think about it, for example, Google is now not serving the US, it's serving everyone. And their mission is to provide the information, to organize the information of the world. So how do you imagine Google is being able to do that? Do you imagine like Google have some sort of massive machine with a massive database with every single website, and then every time any user just clicks search for something, it goes to this massive database and brings the information from there? It doesn't make sense. Maybe in the early days of Google that was possible, but nowadays with billions of users, with a latency of milliseconds, that's impossible. So there was a demand for a new technology and a new hardware that enabled us to have a collapse in the prices of storage systems and the prices of processing units. So, and at this moment, the world became big and fast. Now, I want to take a second to appreciate this moment, because, you know, we take that for granted. But if you think about it, this machine has been, you know, this massive machine, it weighs 10 tons. It fills an entire room like this room. And it do 12,000 floating operations per second. And do you know, like, the mobile in your pocket, that is, you know, you cannot compare it with that machine. Do you know how much powerful is it compared to this machine? It's 100,000 times more powerful than what you are seeing here. So if you think about it, just imagine that you have 100,000 of these machines, 10 tons machines, filling an entire space, and then it got shrinked into something that just gets in your pocket, you know, we take that for granted, but I think this is really fascinating, and we should always appreciate that and think about it when we think about data. So with these changes, with this development in the technology, we had two important developments that we really care about in the data and the analytics work. The first one, is this idea that having everything in one database is not enough. You cannot have enough machine to hold all the databases that we need for billions of users, for billions of transactions. So how do we solve that? What about we separate the data into small chunks and put those small chunks into different machines? And every time you need to get the data from there, you distribute the processing and you distribute the storage. It looks a simple idea, but that was really innovative. That came out in 2003 from Google, and then it was adopted by 2 engineers in Yahoo, and this became what we know nowadays as the MapReduce, which is the foundation of what we call big data processing, like Spark and these kind of technologies. So that was the first one. The other important development is moving from row-based databases into column-based databases. And you know, like if you look at this graph here, you'll see, if you look at this graph here, you will see that the data could be stored in the storage either item by item in the row or item by item in the column. And you might be wondering, why should I care about that? If the end table is the same thing, I don't care how it's stored in the storage. And it turned out to be very important, because if you think about it, most of the analytics work that we do is just on a column base. You take sum of things, you take average of things, right? And all of that is column based. So in this case, having that stored in the storage on a column base make it much faster and much more powerful. This is why when we look at the data warehousing technologies like BigQuery, it's much more effective in the analytics work because how the data is stored in the storage systems. So this was the second important thing that happened around this. The third stage, which is the stage that we live in nowadays, is this massive explosion in sensors. Everything nowadays is tracked. The location where you are sitting now is tracked. Every time you open your mobile, it's being tracked. The moment you open it, how much time are you spending on it? What websites are you using? What apps are you using? All this massive information is being generated every single second about you. And the estimations is around that every single person is generating around 200 megas of data every day for every human being on the planet. So just imagine how much data are we generating nowadays. And at this stage, we say that the world is becoming massive and smart. So at this stage, around the year 2012, we had what we call nowadays the data lake, which is this idea that, you know, we have a lot of data from different sources. So why don't we bring all the data from the different sources into one central place? And why is that? We don't know, but we hope something good will come out of it. And I will come to that in a bit later. So let's just throw everything into one place and collect the data from different sources, do some processing and transformation, have the structured data, the unstructured data, everything in one place. And then at this stage, we had the rise of the cloud. So instead of doing that, just think about everything we said so far. Internet is connected. We have fiber optics that connects everything in a very, very high speed. We have storages that is much more affordable than what we use in the 80s and the 90s. We have a massive processing power, and we have a decrease in the size, in the prices of sensors. So everything is paving the way to what we call nowadays the cloud. And we have a lot of technologies there. So Redshift launched in 2012, and this was the first enterprise-grade data warehouse. And with all of that in mind, let's come back now to our topic, which is the modern data stack. So what is the modern data stack in a very simple way? Well, you think about it, like every one of us in every single business we do, we deal with different data sources. And you need to do something with these data sources. So the first step that you need is to get the data from these data sources into somewhere to process it and do some analysis. So we have what we call the data ingestion layer. And this data ingestion layer includes many tools, like, for example, something like Supermetrics, Fivetran, even Google Analytics, especially with the Google Analytics 4 and the BigQuery integration. And we have things like Airflow or Snowplow. So what do you do after you bring this data in? Well, you need to do some transformation. So we have the transformation layer. Sorry, we need to store it first. So you have the storage layer, and that could be any cloud vendor. And usually when we say the modern data stack, we mean the cloud. It could be anything, really, but usually it means the modern data, the cloud. And then after storing the data, you start doing some transformation for it. There are many popular tools like DBT and Beam and Spark, etc. You can do that also natively on the cloud. Every cloud vendor is providing their own data transformation tools. So what do you do after transformation? Well, you will need to check the quality of the data. Is it the expected values? Do you have null values there? Is the connection broken in some days or some hours? So you need the data quality, the data governance, and there are many tools that is really dominating the market there, like Monte Carlo, Great Expectations, etc. So what do you do after doing the quality check? Well, what's the point of all of this? It's the analysis, doing the actual analysis. We have the last layer of what we call the data, the business intelligence, analysis, visualization, whatever you call it in your company. And all of that needs to be orchestrated together. So you don't have someone or a person sitting every day to export the reports from Google Analytics into your storage, and then from the storage you do the quality check. It doesn't make any sense. You need to automate the whole process. And with that, we have the last layer of all of it, which is the orchestration layer that is done with some tools like Apache Airflow or Dataflow, or if you're using GCP, etc. So we have these kind of tools. So back to the question there, which is, what is the modern data stack? I love this definition from Snowplow, but what I want you to focus on is some of the most important keywords to help you understand what is the modern data stack. And these keywords are, first of all, the scalability. It's something that you can do for a small organization, or you can do it for an extra big organization. So it's scalable. You take what you need. The other part is it's software as a service, so you can pay for what you need. And it has a low barrier to entry, so the infrastructure that you can get today with the modern data stack was not available, was only available to a massive enterprises just 5 years ago. Now, every company at every stage with a very small amount of money and very small amount of investment can set up a modern data stack in literally 20 minutes or 30 minutes. So it has a low barrier to entry. It's pay as you go. It's cloud-based usually, but you can have that on-premise, or you can have part of that on-premise if you want. And it can be platform as a service, and it's a modular. And I think this is probably the most important keyword when we talk about the data stack, the modularity. You know, all this graph that I showed to you, all these layers, you don't need all of that all the time. You might need part of it. You might need even one layer of it or 2 layers of it. You just take what you need. It's not take it all or leave it all. And it has a low maintenance cost, and it's a serverless because usually it happens on the cloud. You can either use a data warehouse or a data lake. And it has an integration with other tools, as we'll see. So this is what we talked about now as an example of the modern data stack. And this is an oversimplified version of the truth. So what is the truth? The truth that we live nowadays is this. This is like a snapshot of the landscape of the data tools that we have nowadays. And as I told you, probably this changed from the moment I started talking. We have probably 10 more tools added to that. So I hope when you came to this session, you did not expect me to share with you the secret stack that will dominate 2025, because you will be disappointed if you came for this. So what I want to share with you is that it's never about the tools. It doesn't matter at all. And I will show you why. But the most important thing that I want to share with you now is putting all of that in mind, seeing how the technology evolved till the moment that we are living in, where all of this is heading, and how can we prepare ourselves to that? Well, I think there are 9 trends that will dominate this industry in the next 2-3 years. And I will share with you this one by one now. So we start with probably one of the most important things. But before we do that, you know, when it gets really complicated, what do we do as analysts? Decompose things, simplify things, try to see any hidden pattern. So this is what we will do now. With all this massive data tools, where do we start in all of this? We start by going back to the basics. And what's the basics? That we really have 2 types of data. It's only 2 types of data. And this data is either operational data or analytics data. Operational data is what we use to run the business. We cannot run without it. It's the list of customers, the list of transactions that you have, the list of categories, all of this data that we need to operate. You cannot work without it. And you have the analytics data that you need to optimize the business and grow your profit and have a better user experience and have a better support for decision making, etc. And the question here is, how do we move things from here to here? Because you need the list of transactions to do analysis, right? How do you move that? Well, we move it with what we call the ETL operations. It's extract, transform, and load. And with that model, we have a problem in this model. Can you guess what's the problem here? This is the paradigm that we've been living in for probably 10 years or 20 years. What's the problem with that model? Can someone guess? Yeah? Oh, I think it will be really hard to... yeah. Sorry, if you can speak... No, I'm sorry, I can't hear you. If you can come, please. Yeah, exactly. Yeah, thank you. So,
you don't know the analytical use cases, so you don't know the transformations beforehand.
Yes, exactly. When you think about the problem here, we are not thinking about the process, we are thinking about people behind the process. Who's doing that in your organization? It's usually the data engineers or the IT people. And then you go to the IT person and say, I want you to get the data from the Facebook Insights. And they have no idea what impressions means, or what reach means, or what engagement means. So when you get, for example, engagement significantly higher than the reach, you know this is wrong. But for the for the IT person, it's okay. They don't understand the difference. So people who do the transformation are not the domain experts, are not the people who do that transformation. So how do we fix that? Well, someone came and say, why don't we flip those both? So it will be ELT, not ETL. What's the difference? We will give this part, the purely technical part, to what we call the data engineers. And we will give the other part, which is the load, which includes the transformation of what we call the analytics engineer. And then we started moving into this new fight. Which one is better? Is it the analytics engineers that started to pick up lately, or the data scientists that has been dominating the industry for some years? So to the future then. What's coming next? Well, I think there will be 9 things that will dominate that trend. And the first one is we will have a rise of what we call the data mesh. And I think you saw many talks already about it. It's getting a lot of momentum and a lot of attraction. And the idea of the data mesh is simply against the direction that we've been traveling in for 10 years. In this direction, the previous direction, it says, let's put everything in one place and hope that we will get something useful out of it. But that was very problematic because of the reason that you shared, which is people who manage the data lake are the data engineers or the IT people that do not understand what needs to be done with this data. So the idea here is different. Instead of having everything into one big chunk, we will separate it. So the marketing team will have their own lake, or whatever you call it. The sales team will have their own lake. The finance people will have their own lake, etc. So it's having this, what we call the data domains. But how do you share the data between those domains? We have something we call the data product. So there is this book by Zamak Dirani. It's called The Data Mesh. I highly advise you to have a look at. It's a very interesting paradigm, and I think it will dominate a lot of things that will happen in the next 2-3 years. And as I told you, it's mainly about the data as a product. And the other part is that we will have a rise of flexible data warehouse, data stores. You see, we have the traditional data warehouses that we used to know, the normal database that we are always familiar with. And if you remember when I told you the column-based database and the row-based database, so the column-based is not something new. It has been there since the 80s, but it just got the momentum when there was enough processing power and enough storage power and enough speed and bandwidth on the internet to support it. Similar thing, we have a new type of databases. So we have the graph databases, we have time series databases, we have a very specialized databases type that will first serve specific purpose. I apologize, we are over time, so we'll just need a couple of more minutes. So this is the second trend that I think will be important. The third trend is that the barrier to EL, extract and load, you know, the first part that we talked about, will go significantly lower. So we have tools like Hyperight that make it really accessible to any team to connect to Facebook, to Shopify, to whatever tool that you are using to bring your data from. And I think this will keep going lower. And by that, that means that having the extract and load will be more affordable to different teams within the same organization. So it's not limited anymore to the IT people or the developers. The fourth trend is the rise of what we call the analytics engineer. And I talked with you about that before. It's getting also a lot of momentum, which is this person that have analytics experience. So they are closer to the domain. But on the same time, they have some software engineering skills, which is the missing part of the whole data ecosystem and the data skills that we have. So we have the analysts, we have the software people, and in the middle, we have the analytics engineers that will fill some part between both. And you know, with this massive growth in this data that will flow into the organization, that raises a governance and security problem. So there will be more interest in processes that have a data governance, because at this moment, anyone could connect, like, you know, the marketing team could just connect your sales data and make it available for their analysis, but on the same time, they might expose it to security risk. If their processes, because they are not data engineers, they are not software engineers, they might not have a full coverage of the security risks. So we need to have more investment in the governance and security. And I think you saw what happened to Google Analytics recently in Europe. So things will get much tougher in the governance and security part. The seventh trend is the growth of what we call reverse ETL. Now, reverse ETL, some people hate that term, and they just call it ETL, because in reality, reverse ETL is just a sort of ETL. And that basically means that, you know, in the stack that I showed to you, we get the data from a specific source. We store it. We do transformation. We do governance. And then we do analysis and visualization. And what happens after that? Well, you share the recommendations with your management or the decision makers to take action based on the outcomes and the findings of what you make, right? And if you think about it, this is a waste of time. What if there is a process where I can take these recommendations automatically at scale and put it back into operations? How could that happen? Let's say I'm doing a scoring for my customers, and that scoring is based on their engagement with the organization in the last 12 months. Can you have that scoring put back automatically in your mailing system, and based on that scoring, you design the whole emailing journey, fully automated? Yes, this is what the ETL is doing. This is like a recently growing field, and there is currently 1 or 2 platforms that really operates in this sphere, but I think there will be a significant growth in this field in the coming years. And the 8th part is about the data culture. Maybe we don't like talking much about it, but it's really very influential. You know, the data is not a first-class citizen in a lot of organizations, and by that I mean you don't have data executives in the C-suite or the senior management. This is changing. We have now what is called a chief data officer, chief analytics officer, whatever that is called, and I think the data will be moving to be a first-class, having a chair on the C-suite and be more influential in the organizations. And the last bit is the growth, the massive growth of the open source. So the open source solutions had this kind of reputation that it's hard to implement, it's not very secured, it doesn't work for large enterprises, but this has changed massively in the last couple of years. And we see now tools that are very, very reliable on an enterprise level that we can rely on. So this idea, we will have more reliance on the open source solutions in the coming years, and now we see this mix of solutions that provide an open source that you can implement it yourself completely free, and also they provide a paid version where you can have that hosted by the vendors. And that's it. Thank you. So